Hello, welcome to today's lesson. Today I'll be talking about scientific notation. So the first thing is, this is what a question will look like. There'll always be one number. This number is less than 10 times 10 to the power of something. And this something can either be positive or negative, and that makes a big difference because the positive ones are for really big numbers and the negative ones are for the really small numbers. So how this works, how the original way that everyone's taught to do it is you put 6.7 and then if the number is positive 6, then you move the decimal place 6 places to the right, and if it's negative 6, you move it 6 places to the left. But let's show you that. So 6.7, 1, 2, 3, 4, 5, 6, 6 places to the right because it's positive. Fill in the zeros. And this decimal point, move the decimal point, right? So we have to move it here. So it's at the end. So the answer is 6.7 million. 6.7 million. So 6.7 times 10 to the power of 6 is 6.7 million. Now, the negative ones people do find trickier, but you put 6.7. Since you're going left, start more right. And then you move the decimal place 6 places to the left. 2, 3, 4, 5, 6. Place the decimal point there. Take out this one. If it's you have to add one more 0 in front of that. And yeah, so that I'm not gonna write that, but it's 67 over a million, I think. Yeah, it's 67 over a million. Now, this is how you originally do it. If it's positive, right, negative, left. Now let me show you a way that I do it, and it actually helps you in converting numbers into scientific notation. So it's not much different. Most people come to this by themselves, but it's if the number's 6, that just means there's 6 numbers. No moving decimal place. There's 6 numbers added just after the first digit. So here we have 6 as the first digit. We have 6 numbers added, so we got 1, and then all the rest is zeros. 2, 3, 4, 5, 6. Way faster, get the same 6.7 million. For backwards, it's a bit more complicated, but you have to add 6 on the other side of the decimal point. So already on the right side of the decimal point, you have 7. And adding 6 on the other side would be 1, 2, 3, 4, 5, 6. Yep. And then your decimal point. We have to add another 0. So that's the faster way that I used to do it. And it gets you the same answer, just you don't have to move any well, you do have to move decimal places, but you don't have to show it with those lines underneath. And it helps you in the next part. Okay. Part 2. This is just the opposite. You'll definitely get these questions if you get the first questions, is when you have a number and you have to change it to scientific notation. Now, what I usually do is remember the first digit when writing scientific notation is just under 10, so we have to, where would our decimal point be? No, that's an eraser, my bad. This was 29. So it would be right here. So our first part of writing scientific notation would be 2.9. And remember, the second way we did it is just the amount of numbers after the decimal point. So 1, 2, 3, 4, 5, 6, 7 times 10 to the 7, which would be 29 million. I don't need to write that. Okay, let's move. And the positive numbers are a lot easier to think about. Okay, for this number, you have to do it the other way. So where is our decimal place gonna be? Here, right? So 9.5 is the first part of our equation times 10 to the what? How many? And this is gonna be negative, right? 1, 2, 3, 4, 5, 6, 7 times 10 to the minus 7. Yeah, so that is how you find this. That is just a quick way to do it. You use scientific notation a lot at the higher level, so it's super useful to get this fast.